Hey again, it's Patrick. We've now come to the final part of the tutorial. This is the tutorial that simulates blood cells animating down a blood vessel or a tunnel. In part 1, we created the geometry of a single blood cell and we gave it material and shading. In part 2, we created the geometry of the tunnel, the shading, and we animated the camera down the same spline, and this is where we stopped. In this part, we will be populating that blood vessel and the tunnel with red blood cells from our original geometry. Let's get started. From my layer viewer, I'm going to select my original blood cell. Okay, unhide it. So I'm not really concerned about the size right now. It is a little bit big, but once we turn it into a particle, we can control the size and variation in sizes for that particle. So I'm gonna move it aside. Okay, so create a particle emitter, so particle systems, and of all these sources I'm going to choose pCloud because pCloud creates a volume of particles for me. So straight from where the camera is, creating from my top, just dragging out a volume. Now I'm going to go into my modifier and turn that volume into a spherical kind of shape. That's because it sort of fits the opening of the tunnel that we have. So spherical, and I'm going to now physically place that at the opening of my tunnel. So it looks like I placed it on the other side. So I'm going to just drag it, make sure it's aligned in the vertical axis. Okay, and sometimes it's quite hard just using the top side view. Okay, so this using the radius. I tend not to use scale, any kind of scaling on particle systems, because since they're using like forces from icons and they're like dealing with distances and space, so you don't want to mess around with the scale just in case. So most of the time any of these particle emitters and all that has area controllers. If it was a box, it would have width and height. Okay, so it's the same thing when you're dealing with joints and helpers. Most of the time you don't want to mess around with their dimensions in terms of scaling. So I have something like that. Again, I'm going to check whether it's 100% shown. I don't want to be looking at a fraction of that and having something else when I'm rendering. So particle generation, let's just play and move our timeline. Okay, so particles appear, not doing a lot of things. So a lot of things I'm going to do now to tidy up and move ourselves nearer to our goal. So 100 frames and disappear, right? So let's check what's causing this. So I've changed my timeline to 200, yeah, as per our last video. So we needed 200 frames of movement. Here in the particle generation part, we have a display until. So it stopped displaying particles after frame 100, so I'm going to change it to 200. Okay, and let's try, and you see that even now as we're scrubbing, it disappears at frame 100 as well. So what's causing this is life is 101, so I'm going to set life to 201. Okay, so it exists and lives until the very end, the very last frame. Okay, so we can see that the particles are just sitting here and not doing a lot of things. So of course we want the particles to flow along the shape of this tunnel, right? So what I'm going to do is create some forces. Okay, so there are a few ways we can do this. We can create some wind and localize them, so when the particles are here, they are being blown by the wind, and when they're in the later part of the tunnel, they're blown by the wind from the right. So you blow them into the shape of the tunnel like that. But the downside of it is once you change the shape of your tunnel for artistic reason or for whatever reason, you're gonna radically change the placement of your wind. So going along the path of the easiest way and the most flexible. So I'm gonna do something that's less frequently used. path follow. So I'm gonna this is a force that will act on the particles. So I'm gonna just do that, create an icon, go to my modifier, and it now asks me to pick the path. So I should pick my original path that generated the camera path that generated the tunnel. So it's path follow, no, it's path spline. So I'm going to pick my shape object and then use my H key to bring up the object picker, and then I have path spline. So I'm gonna hit pick. We must ensure that it updates here. Sometimes I like to do double clicking and somehow it's not updating and it's not selecting. So okay, so now let's see what we have. We have our particles. So to make that easier to see, I'm going to select my particle object, change them to mesh. Okay, not necessarily our blood cell geometry yet, but I'm going to change them to object type, particle type, and then I'm just going to change it to sphere first. Okay, and then up that size so that I can see it. Okay, so nothing's happening, right? That's because I haven't linked that to the particle. So bind to space warp and select the space warp and then link it. I'm gonna move my viewport so that I can just easily do this, okay, instead of like mistakenly select the geometry. So then now we have particles moving along my tunnel. Okay, so first off, it's working exceedingly well. You can see that my cluster of particles are doing that. I can see that they keep going even after the tunnel, and I can see that they finish their entire journey from the start to the end of the tunnel in 30 frames. Okay, so I'm gonna just select that again and make it easier to see in the viewport, and I'm going to just scrub the timeline, and we see that in frame 30 it just finishes and it keeps going like an offsetted repeat of the same shape over and over and over again. So that's gonna have to do with the options in path follow space warp. So I'm gonna go to the modifier panel and check it out. So start frame, and the travel time is 30 frames. So that was why we got the frame 30. So we're gonna make it travel like maybe 180 frames. So travel time 180 frames, and with the particle selected, I'm going to. So we start seeing that this particle travel sort of comes to the end of 180. But something interesting happened. When we traveled 30 frames, it followed the path exactly, but now it's like straight away from that path. So let's again take a look at the options. I can see that my last frame, interesting why it's called the last frame, is 100. So therefore my particles, the space warp stopped acting on particles after frame 100. So they just went on the last known direction. Okay, what we need to do now is last frame say that it's 201 or 200. Okay, so now you can see that the particles are behaving as we intended for them to. Now they're still overshooting the end of the tunnel. So let's go back to my options and see what we have. Okay, I'm gonna do some variation on the speed. You can see that my jolly group of particles are just traveling and exactly at the same speed, and the distance between them doesn't change. Okay, so we're soon going to fix that. Click on this and have some variation in the travel time. So maybe like 10%. Okay, so now when I scrub my timeline, I can see that so very slightly the spacing between the particles are starting to change. So if I want to make that even more pronounced and visible, I'm going to change it to 30%. So you can see that at frame 200 the particles travel, the slowest particles are here and the fastest particles are here. Okay, so maybe I don't want to make the variation so large. So staying at the last frame, I can see how wide that range, the difference in speed is. So I'm going to do a 20, okay, or even a 10. Okay, so maybe I'm happy with slowest particle being here, okay, and the fastest particle being here. So when the particles exit that tunnel, it's no use to us. Okay, let's say that my camera is going to stop somewhere here and looking outside of this blood vessel. So I'm going to further adjust. Okay, I'm just going to change the color of this particle to something that we can actually see without selecting it. So I'm going to change this and the travel time from 180 to 200. Okay, and well, maybe 220. Okay, so you see that by compensating for that, I am just making sure that at frame 200 my fastest particle doesn't leave that the exit of that tunnel. Okay, so that settled my general speed of my particles. Okay, so the next thing I want to do is instance my geometry onto my particles. So just select this and P cloud, my particle cloud, go into the particle type. So before that we had instance particles. Now I'm going to do an instance geometry, and you can see that all the default shapes are grayed out, and then here it becomes active and it's asking me to pick an object. So I'm just going to pick and then pick on my original mesh. So you can see that for each particle it's taken on the shape of my original blood cell. So it's too big, so I'm going to go up to my particle generation, and under the size I'm going to put 1. Okay, not too bad, but still too big, so I'm going to just put 0.5, half that. Okay, it still looks to be big, so I'm going to do a 0.3. Okay, so now it looks still too big, I think. So 0.2, and then give it a variation of like 25% maybe. Okay, so I start to see differences in size, but they're still too orderly. So I'm gonna do a variation in rotation and the facing, the orientation that they're facing. So that happens in rotation and collision. So right now they are spinning, but it takes like 10,000 frames for them to complete one revolution. So I'm going to shorten that and make them have some kind of spin. So maybe like 200. So now when we drag our timeline, we can see that, okay, why don't I just view the animation through the camera? Okay, you can see that they're sort of like spinning, and from here, let's hope that we can see it. Okay, let's say I'm happy with this speed, and then of course I'm going to give it some variation. Everybody's spinning at the same speed, so spin time we had 200, variation, let's say give it like 40%. Some are spinning like almost half of that, yeah, 150%, and some are spinning at like 40%. So it doesn't fit our problem where at the start everybody is still facing the same orientation. So phase solves that. So out of phase, I'm gonna drive everybody out of phase by like 45 degrees. So you can see that everybody is off by 45 degrees in a random rotation. However, everybody is off by exactly 45 degrees. So I'm going to give it a variation of like 20% or like even 80%. Okay, so on top of this random orientation, I'm going to make that starting orientation, starting angle of rotation to be random as well. So okay, so then I achieve a truly random kind of. Right now that's not really visible because my blood cell is just a disc, right? But when you have like objects that you can easily identify where they're pointing, you might get a problem. So this workflow actually is not bad. Let's take a look at where we are and take a look at how our particles are behaving. Okay, not too bad. So they are like traveling independent of each other in a sort of a more random and organic way. Something that we noticed from this camera just now when we in our brief look is particle intersection. So max p-cloud particles are not aware of each other. They are not aware of the walls. Okay, of course we can make them collide with the walls, but making them collide with each other is tricky. Most of the time it doesn't work. So but there are a few tricks that we can do. Okay, if I turn on interparticle collision right now, they wouldn't travel down the path. Sort of like path follow would just not work. So I'm gonna turn that off. Okay, I'm gonna introduce you to this seed. Okay, so this controls where within this volume the particles are born. There is already a randomness to it, but it is an organized kind of randomness. Every particle is born in a predefined position, location within that volume every time, and it's based on this number. So this number generates a random value for each of the particles. So if I don't like how they are like clustered together in the center, okay, I'm going to generate a new random number, which then randomizes the locations and the orientation of the particles. So this uniqueness actually applies for size variations, and orientation and spin speed. Okay, so now it looks like okay, this is the last thing that I want in my animation, is to have some particle like intersect with the camera, go inside the geometry and exit that. Okay, so between all the controls that we have, like the speed and the randomizing of the speed along that path, I would go and tweak each one of them and keep randomizing them, like plus a little bit, minus a little bit, or adding on to the variation of, for example, this path follow object controls the speed of all these, so it just happens to be like you know, the camera traveled through it, so I might want to up vary the speed a little bit, like 20%. However, you can see that at the last frame it's a little bit different, but just try and play around with the. Okay, so that was like 10%, and then we had that camera intersecting that object, but it may already get better if you just put like, you know, 11.8% maybe. Okay, so it would have like spin off, and then, well, maybe I sort of like that kind of like close encounter with that view or whatever. Okay, so just to show you that a little bit of value, especially when you come very close to that object, it makes a big difference. Okay, the next thing that we're going to address is the number of particles. Of course, now the particles are quite like sparse, so that's why we are not having a lot of problem with particles intersecting and eating into each other. So I'm gonna just tentatively go and bump up that amount. So having selected my p-cloud, I'm going to up that to double. So, and of course, one more problem is the particles are traveling together with the camera. Okay, we're gonna fix that soon. We're gonna strive to have at frame 0 already the tunnel filling up with particles. Okay, let's say I need to have 20 this kind of density for my particles, and they're all eating into each other. So like I said, there's not a lot of things that I can do, but the first thing that I would do is to actually reduce that size. Okay, so immediately you don't like eat so much into your neighbor. So 0.12 maybe. Okay, so yeah, of course, really depends on the art direction and the look that you're going for, but let's say I'm very happy with this one, but I can see that right off I have some particles intersecting. If if it's not being seen by the camera, I wouldn't care about that, but yeah, on the first frame I'm seeing it, so I'm just going to hit the unique button again. Okay, now it looks good. Okay, I'm gonna just quickly run through once. Okay, I don't see particles intersecting. Very good. So now let's uh, end this part of the video, and I'm going to extend the last part to have our particles populate that tunnel even on frame 0. So see you on the next part.